Hey there. Welcome to another complimentary webinar from Craft Brewing Business. I'm Chris Kroll, one of the editors at CBB, and I'll be moderating today's presentation, Protect the Quality of Your Brew Lenticular Filtration Options for Craft Breweries. First, I'll be going over some housekeeping items, and then I'll introduce our speakers. During the presentation, we will have a Q&A session at the end. We encourage you to participate by typing your question into the Ask a Question panel in the left-hand portion of your screen. And you can ask those throughout the webinar, and we'll get to them at the end as time permits. We'll also, if we can't get to all of them, be answering them offline as well, via email. So just fire them away. To optimize your viewing experience, please close any programs that may be running in the background. You can also maximize your viewing window by clicking the box with the X at the upper right-hand corner of the slide. And at this time, I'll introduce today's panelists, Kelly Beebe and Brett Kosmicki. Kelly is the scientist and laboratory lead for Pall Corporation. She started working with Pall Corporation in 2007 in the microbiology laboratory. In 2012, she joined Pall Corporation's food and beverage division. And throughout this time, she had the good fortune to work with many breweries across North America, supporting their laboratory and filtration needs. She's achieved certifications from the Seibel Institute of Technology and Brewing, Wine and Spirit Education Trust in Spirits, and Court of Master Sommeliers in America and Wine. It's a lot going on with Kelly. She currently resides with her husband and two Boston Terriers in New York. And then we have Brett here, who's a simple man, who's the cellar manager for Founders Brewing Company. He's been with Founders for over 13 years, focused on managing the cellar operations for 11 of those years. Great experience, both sides here. And with that, I'm going to turn things over to you there, Kelly.
Great, thank you. So welcome to Pall Corporation's webinar on protecting the quality of your brew, lenticular filtration options for craft breweries. As we just went over, my name is Kelly Beebe, and I will be your speaker today, along with Brett Kosmicki of Founders Brewing Company. Thank you for joining us. During today's webinar, we will briefly review shelf life and more thoroughly cover filtration, specifically lenticular filtration, its technology, and options, including carbon media. When discussing shelf life, we are referring to wanting our beers to stay fresh for an extended period of time. Freshness can relate to a beer's appearance, taste and feel, as well as microbial stability and others. Some challenges we may experience are an increase in competition causing beer to be on the shelf longer, agitation during distribution, which can speed up the aging process. And some existing strategies to extend shelf life include minimizing dissolved oxygen, which is already very low, and refrigeration, which may not be easy to implement due to limited control during distribution and how customers handle it. So what else can aid in shelf stability? Filtration. We can filter out a certain amount of solids such as proteins and polyphenols that would later on react to form haze or change the body and fullness of the beers. We can filter out microorganisms that would cause spoilage, and we can filter out yeast that have a risk of autolyzing, which can give off flavors and cause impacts to foam stability. Colloidal stability is influenced by the natural reaction of proteins and polyphenols, and many other compounds can be involved in beer haze, such as polysaccharides, starch, yeast, bacteria, etc. With filtration, we are removing certain amounts of these compounds to achieve clear beer. Clear beer is anything less than 4 NTU or 1 EBC. Now, due to a beer's low pH, ethanol content, anaerobic condition, and isohumulones or hops, it has some inherent microbial stability, meaning that some microbial growth is already inhibited. However, there are some microbes that survive this environment. Examples of the beer's foliage bacteria include Lactobacillus, Pediococcus, Pectinatus, and Megasphaera, as well as the yeast Brettanomyces and Diastaticus. So how can we achieve a more shelf-stable product? With the addition of filtration, specifically lenticular filtration and depth sheet media. Now, before we continue, we're going to pause for a short poll. Okay, So, moving on. Lenticular filters are built from cellulose depth sheet media, which has advantages in its different filtration mechanisms, such as surface and depth filtration, which make it difficult for particles to make their way through, and adsorption, where particles, especially colloidal particles, adhere to the media. Modules can be vertically stacked up to 4 high in enclosed systems, which enable hygienic operation with minimal product losses and minimal dissolved oxygen pickup in a small footprint. Advantages for the operator include no handling of filter powders, easy training, and generating consistent results. Here we have a cross-section of the lenticular filter model. The left side is the exterior, so you can see my pointer here. And on the right, we have the internal core here. Our flow direction is going to start from the left. It's going to pass through the filter media and travel through to the center core. The inside and outside separators, shown in blue and red, are made of polypropylene that give the module rigidity and robustness during steaming and back flushing. Okay. So here you can see these are the filter sheets. Okay. Now for an in-depth look at our depth sheet media. As I mentioned previously, cellulose fibers primarily make up the porous matrix, as shown on the left here. So here's our cellulose fibers. Next, we have additives such as diatomaceous earth and perlite to aid in filtration and/or adsorption, shown in the middle here. And finally, on the right, we have the resins to provide wet strength so that the cellulose maintains its form, porosity, and structure. So here. Okay. Filter sheets are available in many different grades to cover applications from coarse particle filtration, colloidal removal, and microbial reduction, all common tasks within the brewing process. The K700 and K900 shown on the right are good options for a single stage without a centrifuge to achieve a clear beer with a long lifespan. K300, right over here, is a good choice for a single stage post-centrifuge. You can also utilize a multi-stage setup with coarse filtration and fine filtration, such as K700 to an EK or a K100. Due to the various mechanisms, you may see a greater range in retention rates than what is shown here. Here we are looking at the water permeability through the various grades of sheet media. The more coarse or open the grade, the higher the permeability. There are two sizes of Super Disc 2, the 12-inch diameter and the 16-inch diameter. 12-inch has a surface area of 1.8 square meters, which is 19.3 square feet, and the 16-inch has a surface area of 5 square meters, which is 53.8 square feet. Flow rate is about 10 barrels per hour per 16-inch module. Okay. Once you have your lenticular filtration in place, what are some of the best practices? Prior to filtration, we're going to rinse and sanitize, and both of these are in the forward flow direction. Primary rinsing is to remove any residual cellulose dust from the manufacturing process and to precondition the media for the filtration. This is sent to drain. A 10-minute rinse at 7 GPM is recommended for one 16-inch filter module. Next, we're going to sterilize and sanitize with hot H2O, about 80 to 90 C, for 20 to 30 minutes, and this is done in the forward direction only. If hot water is limited, you don't need to flush at a high speed. Flush can be just fast enough to maintain high temperature or recirculated, and worst case, you can run through with hot water, then seal up the system and hold for 30 minutes. As you run at a constant flow rate with a pump, the differential pressure will slowly increase over time until the buildup of particles causes it to suddenly spike. This is called the knee of the curve, right over here. We want to initiate a backflush prior to this, roughly around 7 to 10 psid. However, if you're running at a constant pressure, pushing with CO2 from a tank, then you will not see this effect. Instead, what you'll see is a decrease in flow rate. And you'll want to initiate backflush when you decrease your flow rate significantly. When it comes time to backflush, we are going to start at a low flow rate, then increase gradually to ensure the differential pressure is less than 7 psid. We also want to split the flow at the top and the bottom of the housing to ensure all modules are flushed. We also want to ensure the backflush plates were installed prior to first use, as shown in the middle and right photos here. After filtration, we're going to rinse with cold water in either direction, and our goal for this step is to be foam free. You may still see color, and that's okay. Next is the warm water rinse in either direction. Water temperature should be between 60 and 65 C. This is a good way to dissolve some proteins from the media. Our goal for this step is to be foam free as well. And again, you may see color. After these rinses, we can sanitize or sterilize, just as we did during startup. And this again is the forward direction only with hot water at 80 to 90 degrees C. If you need to store your modules, you can either push out the hot water with CO2 and pressurize to 14 psi for overnight storage, or for anything longer, you can store with citric acid around 3 pH. And our goal is to prevent microbial growth with these storages. Okay. Here we have an example of a single stage 4-high K900 in a brew pub that produces 30 barrel batches 2 to 3 times per week. This is a coarse filtration to achieve a visual clarity. The filter life was about 1,500 plus barrels. And please note a racking arm or standpipe must be utilized in the aging tank. Okay. Another example of single stage filtration, but this time we're post centrifuge. Due to having much less solids post centrifuge, we were able to use a tighter grade of sheet media. In this case, it's the K300. We're running 250 barrel batches through 2 4-high modules in parallel, and the filter life being 30,000 barrels or 6 months production. Compared to the previous example, this setup is getting 10 times the filter life per module with a tighter grade. This is great for the beers you want extra clarity and shelf life stability, similar to like a lager. And I think Brett can speak to some experiences with this one.
Yeah, thanks, Kelly. That was great. So this is similar to the operation that at Founders we now employ. And you know, in my 13 years career doing this stuff all on cold side, if you'd have told me 6-7 years ago that I'd be here giving a plug to use of filtration, I spat my beer right out. But you know, and as a longtime brewer doing this kind of stuff, I've tried it all. And you know, before this haze revolution, everybody was trying to make clear beer, but doing it the simplest way possible. And that had a lot of us using a fining agent of sorts and racking into however many tanks it took. And maybe some of you all in the call are still doing that. Well, we eventually outgrew that. This wasn't appropriate anymore. So we finally, you know, we bid it and got the centrifuge, and that's great. And you know, some of you on the call probably use a centrifuge. I can at least see that no one is a DE user, which is great, because I think we all know nightmare stories of those applications. But while centrifuges, they certainly do a great job, you know, making bright beer at the outlet, what we tended to notice, and this was depending on the style we would make, is that eventually you would still fall victim to that colloidal precipitation of sorts, where whatever protein and polyphenols were left, they would, you know, agglomerate together, and you'd end up with flakes and that kind of stuff, and you end up with a cloudy beer, you know, as it developed into a permanent haze. So, you know, that's not a big deal, maybe with your IPA or maybe any brand that you don't particularly care about the level of clarity and shelf. But we found that with a lot of beers, you know, lagers in particular, the classic one that comes to mind, we needed some form of processing technology, and got hooked up with Pall for these super discs. They're great because, you know, they're pretty modular. The media are easy to work with, and you know, as Kelly's gone on to mention, the K series, there's so many options depending on what kind of throughput you're looking at, whether it's got a lot of solids load, like you're not using a centrifuge, or a tighter and polishing filter. And it's been great for us. You know, at the time it was kind of hard to concede that, you know, you could be a filtering brewer without being a filtering of everything you make. And you know, you really got to stop looking at it so holistically and maybe a little bit more discreetly. You know, you're going to want to filter some brands because of what it requires in order to present to your customer for as long as need be. And you know, that may not look the same for every brand, but I promise you, if you think that the centrifuge alone is going to give you, you know, 3 or 4 months of physical stability post package, it's probably not. And if that matters to you, then that's, you know, that's why you're going to be looking at some of these lenticular options. So with that being said, I think now, Kelly, is the time to go into the poll. Should you go to the poll for number 2?
Yeah.
Yeah, who's like me and uses one of these spinny things?
That's the technical term right there, spinny things.
Yeah. Well, actually, what we say in the industry is centrifuge. I don't know if anybody else says it like that, but it's pretty common where I am. Pretty evenly split.
Cool. All right. So thank you for participating in the polls. And now to continue, we're going to cover another type of lenticular filtration, which would be activated carbon. So activated carbon is made from raw materials such as wood or coconut shells, and it becomes activated by steam or chemically with phosphoric acid. The activation creates highly porous structure, which has a very high inner surface area, allowing for very high adsorptive capacities. This provides color and off-odor removals. Okay. Now we're looking at 2 examples of the progress of lenticular filtration. One is with the neutral base from sugars and the other with neutral base from malts. In each photo, the container on the left is our feed or the original sample after fermentation. The middle container has been filtered through sheet media. And on the right, you have a sample that is being filtered through activated carbon. So you can see the color removal demonstrated visually here. Okay. Carbon treatment options include batch process and carbon lenticular sheet media process. Batch process requires frequent cleaning, which is very labor intensive with high amounts of dust particles polluting the process environment. Permits and licensing may be required to clean inside tanks as well as third-party handling for disposals. Additionally, trap filters are necessary to catch loose carbon downstream. Carbon lenticulars offer an enclosed system which is much more operator-friendly, enabling faster processing with low oxygen pickup and easier cleaning. Due to the carbon being immobilized within the cellulose matrix, dust and shedding are eliminated. All right, so here we have an example of a three-stage filtration post-centrifuge. And the pre-filters, the K200 and the EK, are providing great protection for that carbon filter, the AKS, and this helps to extend the life of the AKS. And please note that no trap filter is necessary due to the carbon being immobilized within the lenticular filters. And I think, Brett, you can provide some insight to this one as well.
Yeah, yep. We like many brewers of the day, we joined in the game of making seltzers, and you know, we didn't have a distillate available to us for various reasons, as I'm sure most of you don't. So if we want a nice, clean, neutral base, we still got to ferment some sugar and then do the best with what we got. So we use the AKS. That was the founder's first foray into working with Pall on the lenticular filters. So we do this process. We actually found that we didn't even need that middle filtration step with the K series post centrifuge. That did clean up nicely. You will get some solids that build up in the AKS, the carbon media, if you don't take care of them. What's interesting is you ferment out and centrifuge these filter bases. You think since there's really nothing in it, there's not a lot of yeast that hangs out after fermentation, there's not really many solids. Obviously, we're not dry hopping these, but nevertheless, there's a lot of haze, particulate, solids of sorts that really remain after centrifugation. So you do need something, but you know, I don't know if you guys are working with a seltzer basis still. Maybe you're into the RTD game now a little bit more, but if you want the yeast to make a lot of alcohol, you're getting a lot of stuff that you don't want hanging around, mostly of a sulfur variety. So it seems like activated carbon's come a long way. You know, there's a lot of stories from the past of what it would take to clean these up, but being able to use it in something like the super disc module, you know, it's multi-purpose. We kind of change back and forth sometimes between using carbon filter media and something else maybe for a polishing filter. So that's worked pretty well for us. You know, seltzer's not as popular as it once was, but there's still a lot of other things. You know, brewers continue to be inventive in the space. You know, it's nice to know that we can go back and filter sugar water and actually have it come out still tasting good no matter what it becomes ultimately. But one more note about that, Kelly, is
no worries.
Do not leave your carbon media without treating it with a good wash and a citric acid preservation, because if you think because it looks clean as filtered, you know, seltzer-based media, it will still fall on you enough time. And if you ever have an operator who's got to take one of these apart after not touching it for months on end, they will be quite upset with you. Do not leave them without treating them.
That's a nice tip. All right. Thanks, Brett. Okay. Oh. Can you see the progression of my screen here? There we go. All right. So here we have a study that Paul completed after some carbon filtration trials. So with the implementation of carbon, the AKSFB, we see a reduction in color, aroma, and flavors, etc. The spectral scan on the left shows a sample without carbon filtration, so that's going to be our blue line here. And the other curves show with the addition of the activated carbon, so you can see a decrease in these compounds. And on the table, you see a reduction in the same compounds with the addition of the carbon filters. So specifically, we have these shown here. So I'll leave this up briefly so you guys can take a peek at everything listed. Okay. So another capability of activated carbon is dechlorination of water. Now the AKSFB is a good way to remove chlorine from water in places you don't want to have it, such as mashing or in the rinsing equipment. And you don't want this because chlorine reacts with, chlorine reacts with phenolic compounds, forming chlorophenols, which can impart undesirable flavors and things such as medicinal or plastic or even antiseptic flavors. So I'll leave this up briefly so you guys can see everything on the slide. And I believe that is the conclusion of the webinar. So thank you. And please feel free to ask any questions.
All right, here we go. So yeah, thanks. That was super informative, and I will get to, oh boy, I had something weird. Okay, the first is, do I need a buffer tank between the centrifuge and filter?
So when you're using the SuperDisc 2 modules, you do not need to utilize a buffer tank.
Yeah, can I elaborate on that too?
Absolutely.
So we have it in both applications, and it really comes down to how your overall process is sort of integrated. If you have, so what this comes up is, do I need a buffer tank? Well, the reason you need a buffer tank is you have a bunch of inputs and outputs that are very tightly regulated, and you have to have a buffering volume because you're still looking to inline carbonate throughput even when your centrifuge is interrupted for a discharge, right? So the introduction of a filter, and feel free to correct me where I'm getting off here, Kelly, but as long as the equipment you're using is integrated enough so that if you do have any throughput interruption, you're fine. The filter media seems to take on. We haven't noticed big pressure spikes when we get an interruption in throughput, say from our centrifuge. And the carbonator, it shuts down CO2 supply anyway, right? Because these are linked pieces of equipment. So we haven't found, I mean, it's helpful to have a buffer tank. You've got a new set of challenges unrelated there as well, but it does work just as well to have that media input between your centrifuge and carbonate or whatever else you have. And I didn't know that was going to be the case at first. So we were actually pretty pleasantly surprised that we didn't have like pressure spiking shocks from the centrifuge itself in line. So, you know, that's that was nice, because if you don't have a buffer tank, now you're looking at a lot of extra capital and complication
Right.
to the process. So
Yeah.
Yeah.
That's helpful. And next up here, can I use a peracetic acid for storage?
So PAA is not recommended. It's not preferred. Citric acid is what is preferred, as it's fully compatible with the SD2 modules. PAA is okay for short-term storage, though.
All right.
Mm-hmm.
Do you still use a Biofine / BC30 with the filtered batches?
No. So yeah, well, we were actually able to not use Biofine at all once we got the centrifuge. But so no, and I think with the tightness you're able to get out of the various, you know, lenticular design, maybe from the K series, I can't imagine there'd be any requirement for a colloidal stabilizer from something like Biofine, or, you know, whatever, that silica gel. Cal, you can probably elaborate on that better, but I can't imagine you would need it.
No, I think you said it well, so I think we're good.
Okay, so question here that is kind of on what they need to do to eliminate oxygen pickup. They use a 16-inch lenticular filter. If you guys could read this, might help. And find that our you see what I'm talking about?
No, let me try to pop out the question thing. Okay.
I can speak to it while you're
Sure.
reading it over too.
Yeah.
Yeah, this is a big one. This is a big one. It's near and dear to all of our hearts too, because what the hell is the point of using a filter to get a great looking product if it still spoils far sooner than it otherwise ought to? So yeah, it was a challenge, and if you don't have access to you know, good and de-aerated water supply, it's certainly going to be, you know, a really tough challenge. You know, the amount of product or CO2 that you would need to displace all the atmospheric oxygen is going to be a lot. So, you know, absent a copious supply of deaerated water, you're going to kind of have to make the determination. Now, maybe Kelly, you could comment on the most appropriate way to attempt to displace water and atmosphere that contains a lot of oxygen, whether you're coming from the top or the bottom. We did that same kind of split method where, you know, to rinse top and bottom, and you know, we're fortunate to have the DAW access. We'll put an oxygen monitoring line and just keep flooding it out of multiple avenues until it comes down. But it is a challenge, and I don't know if there's any insider, you know, trade secrets on that you can help us out with, but I'd be all ears.
I think what you explained is pretty accurate. So I'm trying to think of anything else. I don't know if DK are on the call. You don't know of any other ways to minimize
No, I
oxygen
don't.
pickup? Yeah.
No.
Yeah, I think what you said, Brett, is exactly right.
If you're not deaerating your own water at your plant too, it's far easier than you might think. You get a tank full of hot liquor and put a stone in there, hook it up to CO2, you can get oxygen below 10 parts. Given enough time. So, you know, it might be worth it to create a deaerated water supply, even just for that purpose.
Well, the other attendees are being a little shy right now, so I just wanted to just ask if there are, because you guys both deal with questions like this all the time and you have a lot of experience. I mean, is there anything that you know that like you get questions about that you want to you know, clarify here, or bring up maybe that we didn't cover in the presentation, but you know, you've heard or seen that would be good to relay before we end today?
So John's got a question on my SOP for creating deaerated water. So I'm gonna do my best to walk him through it. So assuming you've got a vessel, you know, you start with hot liquor. For one, if you've got a chlorinated water supply that you're not otherwise treating, hot liquor, certainly above 120 degrees, will help volatilize that chlorine off, because you don't really want to be deaerating your chlorinated water. But secondly, the warmer it is, the more readily you will dissociate that oxygen and get it right out of there, and it'll bring that value down as you put in CO2. So you basically are just attempting to carbonate hot water, and then as it cools, it'll become more usable. So, you want to be mindful of that about how you cool it, but it's pretty quick. So your standard carbonating stone that you put in your bright tank works great. Hook it up with CO2 and the hot liquor and, vent it to atmosphere. So, you can use small amounts of pressure, but essentially just let it rip. And yeah, you'll deaerate it as good as any system in my experience. Now it will be pH treated, of course, but.
Great. Thanks so much, Brett.
Yeah, any final thoughts? I mean, I'm other than John here, we don't have anyone else volunteering. So you must have covered it pretty well, I guess, in the in the presentation, I would say.
I spoke too quickly. Hopefully that wasn't the case.
No, I mean, I absorbed it all, and again, if we don't think there's anything else to cover, I'm just going to go ahead and wrap this sucker up. I want to, obviously thank you both for joining us today, and along with the Pall Corporation staff for making this presentation possible. I want to thank all the attendees for joining us today. If you do have more questions, go ahead and shoot them in, but I'm in my wrap-up mode now, so we can answer those offline. The webinar is being recorded. It was recorded. It will be available at craftbrewingbusiness.com. So if you missed, if you know someone that wants to see it, you can refer it to them to download it anytime and check it out. And for more information about Pall Corporation, please visit their website at pall.com, Pall.com. And thank you for taking the time, everyone, and looking forward to hosting more craft beer webinars in the future.
Thanks, everyone.
Bye for now.
Bye-bye.
Cheers.